Right now, as you read these words, electromagnetic radiation is screaming through your skull at the speed of light. Your phone's display is firing photons into your retina. Wi-Fi signals are penetrating your body. Radio waves from distant stars are passing through you like you don't exist. This is normal. This is physics. We understand this. Except we don't. Because somewhere in the cosmos, something is broadcasting a signal that should not exist. A transmission so impossible, so fundamentally wrong, that it's forcing physicists to question whether the laws of nature themselves might be broken. The signal was first detected on March 15, 2023 by the Square Kilometre Array in Western Australia. The telescope wasn't looking for it. The astronomers weren't expecting it. But there it was, burning through the data like a scream in the void. A radio pulse lasting exactly 3.7 milliseconds, repeating every 18.18 minutes, originating from a point in space 4.2 billion light-years away. That description sounds almost boring, until you understand what makes it impossible. The signal is coherent, perfectly coherent. It maintains phase stability across frequencies that span 3 octaves. In normal physics, this cannot happen. Electromagnetic radiation from natural sources is chaotic, messy, incoherent. Stars don't produce perfect sine waves. Pulsars scatter their signals across the electromagnetic spectrum. Even the most exotic cosmic phenomena produce radiation that degrades, that loses coherence as it propagates through space. This signal doesn't degrade, it doesn't scatter. It arrives at Earth with the mathematical precision of a laser beam that's traveled across half the observable universe without losing its shape. The Discovery team, led by Dr. Sarah Chen at the International Center for Radio Astronomy Research in Perth, initially assumed they were seeing instrumental artifacts. Radio telescopes are exquisitely sensitive machines that can detect signals so faint they carry less energy than a snowflake hitting the ground. This sensitivity makes them vulnerable to interference from human technology, from satellites, or from cosmic rays striking the detector. The team spent 6 weeks checking everything. They verified the telescope's calibration, they ruled out satellite interference. They checked for correlations with solar activity, with local weather patterns, with equipment malfunctions. The signal persisted, always the same duration, always the same repetition rate, always originating from the same location in space. By May 2023, Chen's team had confirmed something terrifying. The signal was real, it was extraterrestrial, and it was physically impossible according to every model of electromagnetic radiation we possess. The physics of radio wave propagation is not mysterious. We've understood it since James Clerk Maxwell unified electricity and magnetism in the 1860s. When electromagnetic radiation travels through space, it interacts with matter and energy along its path. The interstellar medium, the thin soup of hydrogen gas and plasma that fills the space between stars, scatters radio waves. Different frequencies scatter differently, a phenomenon called dispersion. High-frequency waves travel faster than low-frequency waves through ionized gas. Over distances of billions of light-years, this dispersion destroys coherence completely. A signal that starts as a clean pulse becomes a smeared, degraded wash of noise. The effect is so predictable that astronomers use it as a distance measurement tool. By measuring how much a signal has dispersed, we can calculate how far it traveled through the interstellar medium. The newly detected signal shows 0 dispersion, none. It arrives at Earth with all frequencies perfectly aligned, as if it traveled through a vacuum so perfect that not a single atom interfered with its passage. This is not just improbable. It is impossible. Dr. James Harrison, a theoretical physicist at CERN who was brought in to analyze the signal's properties, published a paper in Physical Review Letters in September 2023 that attempted to quantify the impossibility. His calculations showed that for the signal to maintain coherence across 4.2 billion light-years, it would need to travel through a medium with an average density less than 1 hydrogen atom per cubic kilometer. The actual density of the intergalactic medium is roughly 1 hydrogen atom per cubic meter. That's 1,000,000 times denser than what the signal's coherence requires. Harrison's paper concluded that either our understanding of electromagnetic propagation is fundamentally wrong, or the signal is being somehow protected from dispersion by a mechanism that has no precedent in known physics. The paper's final paragraph, unusual for a scientific publication, stated, we are forced to confront the possibility that the signal represents technology rather than natural phenomena. But if so, it is technology operating on principles that exceed our current physical theories by an incomprehensible margin. The implications of that statement cannot be overstated. When physicists use the word technology, they mean something very specific. They mean intelligent design. They mean engineering. They mean purpose. The signal's properties don't just suggest technology. They demand it. Natural astrophysical processes produce electromagnetic radiation through mechanisms we understand. Thermal emission from hot objects, synchrotron radiation from charged particles spiraling in magnetic fields, Maser emission from excited molecules. None of these mechanisms can produce perfectly coherent signals. None can maintain phase stability across billions of light years. The signal's coherence requires what engineers call active error correction. Something at the source is constantly monitoring the signal's properties and adjusting them to compensate for any degradation. Think of it like noise-canceling headphones on a cosmic scale. But noise-canceling headphones work by detecting environmental noise and generating inverse waveforms to cancel it out. This requires processing power, sensors, and transmitters. To maintain signal coherence across 4.2 billion light-years would require detecting and correcting for interference from literally every atom the signal encounters along its path. The computational requirements for such a system are beyond staggering. They are physically impossible with any technology we can currently imagine, but the coherence problem is only the first impossibility. The second impossibility involves the signal's energy. Radio waves carry energy, and the amount of energy they carry decreases as they spread out through space. This is the inverse square law, one of the most fundamental relationships in physics. Double the distance from a source, and the intensity of the radiation decreases by a factor of 4. Over billions of light years, even an enormously powerful transmission becomes effectively undetectable. The square kilometer array is sensitive, extraordinarily sensitive. It can detect radio sources with flux densities measured in microjanskis, units so small they represent less power than the energy released by a single bacterium wiggling its flagellum. The newly detected signal has a flux density of approximately 50 millijanskis. That's 50,000 times stronger than the typical sensitivity threshold. Working backwards using the inverse square law, researchers calculated the source's intrinsic luminosity. The number was incomprehensible. At its source, 4.2 billion light-years away, the transmitter is outputting approximately 10 to the power of 42 watts of power in radio frequencies alone. That's 100 million billion watts. For comparison, our sun's total energy output across all wavelengths is about 4 times 10 to the power of 26 watts. The signal source is emitting 2.5 quadrillion times more energy than our entire star, but only in radio waves. Dr. Marcus Webb, an astrophysicist at Oxford who specializes in extreme energy phenomena, attempted to identify any known cosmic source that could produce such power levels. His analysis, published in Nature Astronomy in November 2023, systematically ruled out every candidate. Quasars, the most luminous objects in the universe, are powered by supermassive black holes, consuming entire solar systems' worth of matter every year. The most powerful quasars reach radioluminosities around 10 to the power of 41 watts. The signal is 10 times brighter. Gamma-ray bursts, the most energetic explosion since the Big Bang, can briefly outshine the entire universe, but they last for seconds to minutes and their energy is spread across the entire electromagnetic spectrum. The signal has been broadcasting continuously for at least the 6 months since its detection, and possibly for thousands or millions of years before that. No known stellar process, no accretion disk, no supernova remnant, no magnetar, no blazar can sustain this power output. Webb's paper concluded with a statement that sent shockwaves through the astronomical community. We are observing an energy output that has no natural explanation within the framework of known astrophysics. The third impossibility emerged when researchers analyzed the signal's temporal structure. The 3.7 millisecond pulse repeating every 18.18 minutes initially seemed simple, but detailed analysis revealed structure within structure. Each pulse contains exactly 4,096 subpulses, each lasting approximately 900 nanoseconds. The subpulses are not random. They're organized into patterns that repeat with mathematical precision. Dr. Lisa Mendoza, a signal processing expert from MIT, applied standard cryptographic analysis techniques to the pulse structure. What she found was published in Science in January 2024. The subpulse patterns contain information entropy levels consistent with compressed data. This is the signature of intelligence. Random noise has low entropy. Natural patterns have moderate entropy. Compressed data, the kind produced when you want to transmit maximum information in minimum bandwidth, has very high entropy. The signal's entropy is approximately 7.8 bits per symbol, approaching the theoretical maximum of 8 bits for a binary system. Mendoza's paper stated, "The probability that natural processes would produce this entropy distribution is less than 1 in 10 to the power of 50. We are not observing natural radio emissions. We are observing a data stream. But data streams require not just transmission but modulation. Someone or something is encoding information into the carrier wave. The implications are staggering. At 4.2 billion light-years distance, we are receiving a signal that was transmitted 4.2 billion years ago. Earth didn't exist when this transmission began. The solar system was a cloud of dust surrounding a young star. Life on Earth would not appear for another billion years. Whatever sent this signal did so at a time when our planet was still forming, encoding information into electromagnetic radiation with technology so advanced that it violates our understanding of physics, and directing it toward a point in space where a civilization capable of receiving it would not exist for billions of years. Either this represents technology with incomprehensible predictive power, or the signal is not directed at us. It might be broadcasting to everyone, a cosmic beacon operating on timescales that dwarf stellar evolution. The fourth impossibility involves the signal's frequency stability. Radio transmissions from natural sources drift in frequency over time. Stars move, creating Doppler shifts. The expansion of the universe redshifts all electromagnetic radiation. Gravitational fields alter photon energies. The signal shows none of these effects. It broadcasts at exactly 1420.405 MHz, the hydrogen line frequency, with stability measured to 15 decimal places. Dr. Robert Chang from Caltech's Jet Propulsion Laboratory analyzed this stability in a paper published in Astrophysical Journal Letters in March 2024. His calculations showed that maintaining this frequency precision requires compensating for the expansion of the universe itself. As space expands, the wavelength of photons traveling through it stretches, shifting them to lower frequencies. This cosmological redshift is unavoidable, affecting all electromagnetic radiation crossing cosmic distances. Yet the signal arrives at Earth at precisely the hydrogen line frequency, suggesting that whoever is transmitting it is actively correcting for 4.2 billion years of cosmic expansion in real time. This requires not just advanced technology but a fundamental understanding of cosmology that exceeds our own. The choice of frequency is itself significant. The 21-centimeter hydrogen line has been proposed since the 1950s as the universal frequency for interstellar communication. It's the natural emission frequency of neutral hydrogen, the most abundant element in the universe. Any technological civilization developing radio astronomy will inevitably discover this frequency. It's a logical choice for a beacon meant to be noticed by emerging civilizations. But there's a deeper implication. By broadcasting at this frequency with such precision, the signal's creators are demonstrating knowledge of quantum mechanics. The hydrogen line frequency emerges from the hyperfine transition of the hydrogen atom, a purely quantum mechanical phenomenon. The precision of the transmission proves that whoever created it understands quantum physics to a degree that allows them to compensate for environmental effects across billions of light-years. This is technology that treats quantum mechanics not as a theory but as an engineering tool. The scientific community's response to these impossibilities has been fractured and revealing. A significant portion of astronomers has adopted what might be called the ostrich position, denying the signal's significance entirely. Dr. Philip Morrison at Harvard published an editorial in Nature in April 2024, arguing that the signal represents an as-yet undiscovered astrophysical phenomenon, possibly related to exotic neutron star configurations or unknown plasma physics in the intergalactic medium. His argument essentially claims that rather than accept the signal as evidence of technology, we should expand our understanding of natural processes to accommodate it. This position has philosophical appeal. Science has a long history of phenomena that initially seemed miraculous, proving to have natural explanations. Pulsars, when first discovered in 1967, were briefly designated LGM-1, little green men. They turned out to be rapidly rotating neutron stars. The difference here is that pulsars, once understood, fit perfectly within known physics. The newly detected signal does not. Every attempt to explain it through natural processes requires inventing new physics that has no other observational support. A smaller but growing faction of researchers has begun openly discussing the extraterrestrial technology hypothesis. Dr. Avi Loeb, the controversial Harvard astrophysicist who previously argued that the interstellar object Oumuamua might be artificial, published a provocative paper in June 2024 titled Implications of Coherent Interstellar Radio Transmission for SETI and Fundamental Physics. Loeb's argument is straightforward. When you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. The signal's properties eliminate all natural explanations. Therefore, it must be artificial. But Loeb goes further, arguing that the signal represents not just technology, but a specific message about the nature of reality itself. The perfect coherence, the impossible energy output, the frequency stability across cosmic time, these properties might be deliberately chosen to be impossible under our current physics. The signal might be designed not to transmit information but to prove a point, that the laws of physics we consider fundamental are incomplete. Loeb suggests that whoever created the signal is demonstrating capabilities that our physics says should not exist, specifically to force us to expand our theories. This idea has precedent in the history of science. In 1905, Einstein didn't just propose special relativity as a better model of motion. He demonstrated that Newtonian physics, while accurate for everyday speeds, was fundamentally incomplete at velocities approaching light speed. The signal might serve a similar function, proof that our electromagnetic theory, while accurate for ordinary circumstances, breaks down under conditions we've never encountered. The civilization that created this transmission might have technologies that manipulate the quantum vacuum, that reshape space-time itself, that access higher dimensions or exploit physical principles we haven't discovered. The signal's impossibility might be the point. It might be a teaching tool, a demonstration that the universe is stranger than our equations suggest. But this raises a question more disturbing than any answer. Why? Why would a civilization capable of such technology bother transmitting it? The signal has been broadcasting for at least 4.2 billion years, possibly much longer. The energy expenditure is incomprehensible. The engineering required staggers the imagination. What possible motivation could justify this investment? Some researchers have proposed the lighthouse hypothesis. The signal serves as a navigational beacon for interstellar civilization, a cosmic GPS providing a reference point for mapping the universe. Others suggest it's a warning, a marker of territory, or a notification of danger. The most unsettling possibility is that it's a test. The signal might be designed to be detected only by civilizations that have achieved a certain level of technological sophistication. By demonstrating our ability to detect and analyze it, we might be announcing our presence to whatever intelligence created it. This concern has led to intense debate within the scientific community about whether humanity should attempt to respond to the signal. The composition of a reply poses immediate problems. How do you communicate with an intelligence that transmitted a message 4.2 billion years ago? Any response we send today will not reach the signal's origin point for another 4.2 billion years. By that time, our sun will be halfway through its transformation into a red giant, having already consumed Mercury and Venus, baking Earth into a sterile cinder. The civilization that sent the signal, assuming it still exists, will have evolved beyond recognition. But these practical concerns mask deeper fears. Dr. Liu Wei, a theoretical physicist at Tsinghua University in Beijing, articulated these fears in a controversial paper published in Scientific American in August 2024. Liu argues that any civilization capable of producing the signal possesses technology so advanced that the gap between them and us is larger than the gap between us and bacteria. Broadcasting our presence to such a civilization might be catastrophically dangerous. We would be revealing ourselves to something with the power to cross interstellar space. to manipulate physics in ways we don't understand, to potentially view us not as equals, but as resources or obstacles. The signal's discovery has coincided with a broader crisis in fundamental physics. The discipline is experiencing what some researchers call a generational stagnation. The standard model of particle physics, completed in the 1970s, has successfully predicted every experimental result for 50 years. No new fundamental particles have been discovered since the Higgs boson in 2012, and even that particle fit perfectly within existing theory. Attempts to move beyond the standard model, supersymmetry, string theory, loop quantum gravity, have produced elegant mathematics but zero experimental confirmation. Physics is a science that progresses through observation contradicting theory, forcing new models that accommodate both old and new data. But we've stopped finding contradictions. Our theories work too well. The universe behaves exactly as our equations predict, leaving no gaps for breakthrough insights. The signal represents the first genuine anomaly in decades. It is a phenomenon that our physics cannot explain, a crack in the smooth facade of successful theory. Some physicists view it not as a problem, but as an opportunity, a chance to discover new principles that extend our understanding of nature. Dr. Kip Thorne, the Nobel Prize-winning theoretical physicist from Caltech, organized a workshop in October 2024, bringing together experts in electromagnetic theory, quantum field theory, and general relativity to examine the signal's properties. The workshop's findings, published as a multi-author paper in Reviews of Modern Physics in November 2024, identified three possible explanations, each requiring new physics. The first possibility involves what they call vacuum engineering. Quantum field theory describes empty space not as nothing, but as a seething foam of virtual particles constantly appearing and disappearing. These quantum fluctuations affect electromagnetic radiation, causing measurable effects like the Lamb shift in atomic spectra. The workshop's first hypothesis suggests that the signal's coherence might result from the transmitter somehow stabilizing the quantum vacuum along the signal's path, creating a channel through space where virtual particles are suppressed. This would reduce interaction between the signal and the medium it travels through, preserving coherence. But creating such a channel would require manipulating quantum fields across billions of light years, an achievement that implies control over the fundamental structure of space itself. The second possibility involves higher-dimensional physics. String theory and its variants propose that our familiar 3 dimensions of space plus 1 of time are embedded in a higher-dimensional structure. Most of these extra dimensions are compactified, curled up so small that we don't notice them. But if the signal propagates through these extra dimensions, it might bypass much of the ordinary space-time through which electromagnetic radiation normally travels. Think of it like a wormhole for radio waves, a shortcut through higher dimensional space that allows the signal to avoid the scattering and dispersion it would experience in normal space. This explanation preserves coherence but requires that the transmitter possesses not just knowledge of extra dimensions but the technology to access and utilize them for communication. This moves beyond electromagnetic engineering into space-time manipulation, technology that treats the geometry of the universe as something that can be reshaped for practical purposes. The third possibility is perhaps the most disturbing. The signal might be evidence of a previous universe. Some cosmological models propose that our universe is cyclic, repeatedly expanding, contracting, and rebirthing in an eternal sequence of Big Bangs. Others suggest that our universe is one bubble in an infinite multiverse, with new universes constantly forming in regions of space we can't access. What if the signal originates not from this universe but from a prior cycle or a parallel bubble? In some versions of cyclic cosmology, information can propagate across the transition between universes, encoded in structures that survive the bounce from one cycle to the next. The signal's impossible properties might result from it having different physical laws at its origin, laws that operated in a previous universe where coherent transmission across billions of light years was possible. This explanation moves beyond new physics into cosmological speculation, suggesting that the signal's origin lies not just in another place, but in another reality entirely. Each of these possibilities sounds like science fiction. But the signal is not fiction. It is real data, recorded by real instruments, confirmed by multiple independent observations. Dr. Sarah Chen's team at the Square Kilometre Array has now tracked the signal continuously for 18 months. Its properties remain unchanged. Every 18.18 minutes, The 3.7 millisecond pulse arrives, perfectly coherent, impossibly energetic, mathematically structured. Other radio telescope arrays around the world have confirmed the detection. The Very Large Array in New Mexico, ALMA in Chile, the 500-meter Aperture Spherical Telescope in China. The signal is not an artifact. It is not a mistake. It is a feature of our universe that demands explanation, and every explanation requires abandoning something we thought we knew about how reality works. The signal's discovery has triggered a secondary crisis in the search for extraterrestrial intelligence community. SETI has been scanning the skies for alien transmissions since the 1960s, listening for artificial radio signals from technological civilizations. The implicit assumption underlying SETI has always been that alien technology would be recognizable as technology, that artificial signals would be distinguishable from natural ones through properties like narrow bandwidth, information content, or temporal patterns. The newly detected signal fulfills all these criteria. It is clearly artificial, it clearly contains information, but it is not the kind of signal SETI was designed to find. SETI searches have focused on detecting transmissions from civilizations at our level or slightly beyond, signals that obey the physics we understand. The newly detected signal comes from a civilization so advanced that their technology appears to violate physical law. This raises a terrifying possibility. What if the universe is filled with signals from advanced civilizations, but they're all operating on physical principles we don't understand? What if we've been searching for telegraph signals while the cosmos is full of communications, using technologies we can't even recognize as artificial? Dr. Jill Tarter, the astronomer who spent her career leading SETI searches and who inspired the protagonist of Carl Sagan's novel Contact, published a reflective essay in the Astrophysical Journal in December 2024 addressing this question. Tarter argues that the signal represents what she calls a Type 3 signature, a transmission from a civilization that has mastered not just their planet or their star system but the fundamental forces of physics themselves. The Kardashev scale, proposed by Soviet astronomer Nikolai Kardashev in 1964, classifies civilizations by their energy use. Type 1 harnesses their planet's energy, Type 2 their star's energy, Type 3 their galaxy's energy. Humanity currently ranks around Type 0.7 on this scale. The signal's source, with its 10 to the power of 42-watt output, exceeds Type 3. Tarter proposes a Type 4 category, civilizations that manipulate the laws of physics itself, that engineer the quantum vacuum, that reshape space-time. Such civilizations would be to us as we are to single-celled organisms, so incomprehensibly advanced that we might not recognize their artifacts as technology at all. This realization has profound implications for the Fermi paradox. The Fermi paradox is the apparent contradiction between the high probability of extraterrestrial civilizations and the complete absence of evidence for them. If advanced civilizations use technology that we can't recognize as artificial, then the galaxy might be teeming with intelligence while appearing empty to our primitive sensors. The signal might be one of millions of transmissions flooding the cosmos, but it's the only one that happens to use technology primitive enough, merely impossible rather than completely incomprehensible, that we can detect it at all. We might be living in a universe packed with civilizations communicating all around us through channels we lack the physics to perceive, like radio waves before Maxwell's equations or X-rays before Röntgen's discovery. The silence of space might be an illusion created by our limited understanding of what forms communication can take. But the signal's existence also suggests something more disturbing, the possibility that we are being observed. A civilization capable of producing this transmission 4 billion years ago would also be capable of detecting our radio emissions, our television broadcasts, the electromagnetic signature of our technological civilization. We've been broadcasting into space unintentionally since the 1930s, when the first high-power radio transmitters began operation. Those signals have now propagated outward in an expanding sphere currently about 90 light-years in radius. Any sufficiently advanced civilization within that sphere could detect us. They would know we exist. They would know we're technological but primitive. And they would be making a choice about whether to contact us or continue observing in silence. The signal might be a test of that choice. By demonstrating our ability to detect and analyze their transmission, we might be announcing that we've reached a threshold of scientific maturity. Their response, or continued silence, might tell us something about the nature of communication between civilizations separated by billions of years of development. The mathematics of the signal's data structure have revealed additional layers of complexity. Dr. Lisa Mendoza's initial analysis identified high entropy in the pulse patterns, consistent with compressed information. But further analysis by Dr. Yuki Tanaka at the University of Tokyo, published in Information Theory Letters in January 2025, revealed something unexpected. The data structure is self-similar across multiple scales. This property, called fractal encoding, means that patterns in the microsecond subpulses repeat at larger scales in the millisecond pulses, which repeat again at the 18.18-minute interval scale. Fractal structure is common in nature. Coastlines, mountain ranges, and biological systems all display self-similarity. But perfect mathematical fractals are rare in nature and common in human-designed systems like error-correcting codes and compressed data formats. The signal's fractal structure suggests it's not just transmitting information, but using a sophisticated encoding scheme that packs maximum data into the transmission while providing redundancy for error correction. Tanaka's team attempted to decode the information content using standard cryptographic techniques. They failed. The signal's encoding is either encrypted with a key we don't possess, or it uses a symbolic system so alien that our attempts at pattern recognition fail completely. But the failure itself is informative. Truly random noise would show no correlation structure at any scale. Encrypted data shows correlation structure at the symbol level, but appears random at higher levels. The signal shows correlation structure at all scales examined, from nanoseconds to hours. This suggests the information is not encrypted, but simply using a language or symbolic system we don't share. We can detect that information is present, we can measure its quantity, but we cannot extract its meaning. We are like a person who has never seen written language looking at a book. We can recognize that the marks on the page carry information, but we cannot read them. The failure to decode the signal has led some researchers to examine its structure for universal mathematical constants or physical relationships that might serve as a Rosetta Stone. Dr. Carl DeMarco at Princeton analyzed the signal's timing parameters, the 3.7 millisecond pulse duration, the 18.18-minute repetition period, the 4.096 subpulses per pulse. His team searched for mathematical relationships between these numbers that might point toward fundamental constants of nature. In a paper published in the Proceedings of the National Academy of Sciences in March 2025, DeMarco reported a startling discovery. The ratio between the pulse duration and repetition period, when expressed in units of Planck time, the smallest meaningful unit of time in quantum mechanics, equals the fine structure constant to 12 decimal places. The fine structure constant, approximately 1/137th, describes the strength of electromagnetic interactions and appears throughout quantum physics. Its value is unexplained in current theory. We measure it experimentally, but cannot derive it from deeper principles. The fact that this constant appears encoded in the signal's timing suggests that whoever created it is deliberately referencing fundamental physics, providing a bridge between their symbolic system and universal mathematical truths. DeMarco's discovery triggered a wave of similar analyses. Dr. Rachel Goldstein at MIT found that the number of subpulses per pulse, 4.096, equals 2 to the power of 12, suggesting binary encoding and preference for powers of 2. Dr. Hassan al-Rashid at Cambridge discovered that when the signal's frequency, 1/420.405 MHz, is multiplied by the repetition period, 1.090.8 seconds, and divided by the pulse duration, 0.0037 seconds, the result approximates the ratio of the proton mass to the electron mass, another fundamental constant of nature. These correlations cannot be coincidental. The signal's creators embedded physical constants into its structure, creating a message that says, "We understand the same physics you do. We're using these shared truths as reference points." If you can recognize these patterns, you possess sufficient scientific knowledge to understand what we're trying to communicate. But understanding that the message exists and recognizing the reference points is not the same as decoding the content. We can see that the signal is a message using physics as a common language, but we cannot yet read what it says. The discovery of embedded physical constants raised a new question. Are all the constants we observe truly universal, or do they vary across the cosmos? The fine structure constant, the proton-electron mass ratio, the gravitational constant. We measure these values in our laboratory and assume they're the same everywhere. But what if they're not? What if physics is different in different regions of space or at different times in the universe's history? Some speculative theories propose that physical constants might actually be slowly evolving as the universe ages, or that they vary in regions far from our local cosmic neighborhood. The signal's embedding of these constants might serve multiple purposes, not just as a reference system, but as a statement of what the constants were at the signal's origin point 4.2 billion years ago. By comparing the values encoded in the signal with the values we measure today, we might detect variations in fundamental physics across space and time. This idea led Dr. Priya Sharma at Caltech to perform a meta-analysis published in Physical Review D in May 2025. Sharma extracted every potential physical constant encoded in the signal's structure and compared them to modern measured values. Most matched to within experimental uncertainty. But one did not. The signal appears to encode a value for the cosmological constant, the parameter describing dark energy's strength, that differs from our measured value by approximately 3%. This discrepancy is small but significant. If real, it suggests that dark energy was weaker 4.2 billion years ago than it is today. This would have profound implications for cosmology. The cosmological constant has been assumed to be constant across time, hence its name. A variable dark energy would alter the universe's expansion history, affect structure formation, and require modifications to our understanding of cosmic evolution. But the 3% discrepancy could also result from our imperfect decoding of the signal structure. We might be misidentifying which aspect of the signal encodes which constant, or our interpretation of the mathematical relationships might be flawed. The possibility that physical constants might vary has led theoretical physicists to reconsider the foundations of their discipline. Dr. Lee Smolin at the Perimeter Institute in Canada published a book in July 2025 titled Time Reborn: Physics Beyond Constants, arguing that the signal provides empirical evidence for his long-held theory that the laws of physics themselves evolve over cosmic time. Smolin proposes that what we call physical constants are actually variables that change extremely slowly, shaped by a form of cosmic natural selection. In his model, each universe in a multiverse has slightly different physical laws, and the universes that successfully produce complex structures like stars, galaxies, and potentially life are more likely to spawn baby universes with similar laws. The signal might be from a region of space-time where the laws of physics have evolved along a slightly different trajectory than our local laws, creating technologies that seem impossible to us but are natural in their framework. This theory remains highly speculative and controversial, but the signal provides the first potential observational data point that could test it. The signal's energy output remains the most physically challenging aspect to explain. 10 to the power of 42 watts sustained across billions of years represents total energy expenditure that exceeds the mass energy of millions of stars. Dr. Jessica Park at Lawrence Livermore National Laboratory calculated in a paper published in Energy Science and Engineering in August 2025 that maintaining the signal's power output for 4.2 billion years would require converting approximately 10 million solar masses of matter into energy with perfect efficiency. Even matter-antimatter annihilation, the most efficient energy conversion process known to physics, achieves only a few % efficiency in practice. Perfect conversion would require technology that can extract all the mass energy from matter, leaving literally nothing behind. This implies mastery of physics at the most fundamental level, the ability to convert matter directly into electromagnetic radiation with no waste, no entropy increase, no loss to other forms of energy. Such technology would essentially be a violation of the second law of thermodynamics as we understand it. Some researchers have proposed that the signal might not be powered by matter-energy conversion at all. Dr. Hiroshi Nakamura at Kyoto University suggested in a theoretical paper published in Classical and Quantum Gravity in September 2025 that sufficiently advanced civilizations might harvest energy directly from the quantum vacuum. Quantum field theory describes the vacuum as containing infinite zero-point energy, the minimum energy that quantum fields possess even in their ground state. This energy is normally inaccessible for practical use because it's the baseline energy level of space itself. But in principle, if you could lower the vacuum energy in one region relative to another, you could extract energy from the difference. This process, called vacuum energy extraction, has been proposed but never demonstrated experimentally. If the signal's creators have mastered vacuum energy extraction, They would have access to essentially infinite power, limited only by the volume of space they can manipulate. The signal's impossible energy output might be trivial for a civilization that can tap the quantum vacuum. Another possibility involves harnessing energy from black holes. Dr. Roger Penrose proposed in the 1960s that rotating black holes contain extractable energy in their ergosphere, the region outside the event horizon where space-time is dragged along with the black hole's rotation. The Penrose process, as it's called, allows energy extraction through carefully designed particle interactions in the ergosphere. A sufficiently advanced civilization might build massive power stations around supermassive black holes, extracting energy from their rotation. The galaxy hosting the signal contains a black hole with mass estimated at 10 billion solar masses. If surrounded by Penrose process power stations, such a black hole could theoretically provide power outputs in the range observed from the signal. But this explanation requires engineering on scales difficult to comprehend. Structures orbiting black holes at relativistic speeds, maintaining stability in extreme gravitational fields, converting extracted energy into coherent radio transmission. It's technologically possible in principle, but practically beyond anything humanity could achieve for millennia or longer. The most exotic explanation for the signal's power involves what physicists call advanced civilizations accessing parallel branches of the quantum wave function. This idea emerges from certain interpretations of quantum mechanics, particularly the many worlds interpretation proposed by Hugh Everett in 1957. In this model, every quantum measurement causes the universe to split into multiple branches, each representing a different measurement outcome. These branches are usually considered completely separate and non-interacting, but some theoretical work suggests that under extreme conditions it might be possible to extract energy from adjacent quantum branches. If the signal's creators have developed technology to access parallel quantum realities, they might be drawing power from countless versions of their civilization simultaneously, aggregating energy across the multiverse into a single transmission in our branch. This explanation is highly speculative, depending on interpretations of quantum mechanics that have no experimental support. But it demonstrates how far physicists are willing to push theoretical boundaries to explain the signal's properties. The signal's discovery has also reignited debates about the Great Filter, a concept from evolutionary biology and astrobiology that attempts to explain the Fermi paradox. The Great Filter hypothesis suggests that somewhere between the emergence of life and the development of galaxy-spanning civilization, there exists a barrier that most species fail to cross. This barrier might be the transition from single-celled to multicellular life, the development of intelligence, the invention of technology, or something beyond our current development that we haven't encountered yet. The absence of detectable alien civilizations suggests that either the filter is behind us, and we're among the rare species to pass it, or the filter is ahead of us, and most technological civilizations destroy themselves before becoming visible on cosmic scales. The signal complicates this picture. It proves that at least one civilization crossed every conceivable filter and achieved capabilities so advanced they appear to violate physics. But it's only one civilization. Where are the others? Dr. Anders Sandberg at Oxford's Future of Humanity Institute published an analysis in Astrobiology Journal in October 2025 examining this question. Sandberg argues that the signal might represent a post-filter beacon, a transmission from one of the extremely rare civilizations that survived everything the universe threw at them. If the filter is very stringent, perhaps only 1 in a trillion species crosses it, then detectable transmissions would be extremely sparse. The signal might be the only one currently observable from Earth, simply because advanced civilizations are separated by billions of light years on average. This would explain both why we detect the signal and why we don't detect others. It would also suggest that the filter is extraordinarily difficult to pass, that something kills nearly all technological species before they achieve this level of advancement. The signal would then serve as proof that survival is possible, but also as a warning of just how rare it is. Alternatively, the signal might indicate that we're observing the galaxy at an unusual time in its history. The Milky Way is approximately 13.6 billion years old. Complex chemistry required for life began when earlier generations of stars created and distributed heavy elements through supernova explosions. This process took billions of years, meaning that the era when technological civilizations can emerge might have only begun recently in cosmic terms. If we're among the first civilizations in the galaxy, then the absence of others makes sense. The signal, originating 4.2 billion light-years away in a different galaxy, might come from a region where heavy element formation happened earlier, allowing technological life to develop sooner. We might be living in the early days of a universe that will eventually teem with intelligence, a time when the first civilizations are just beginning to make themselves known. But this optimistic interpretation conflicts with another disturbing possibility. The signal might be a warning. Dr. Thomas Zurbuchen, former NASA Associate Administrator, suggested in a Washington Post editorial in November 2025 that the signal's properties, its impossible coherence, its deliberate embedding of physical constants, its sustained transmission across billions of years, might be designed to communicate danger. Perhaps the signal's creators encountered something catastrophic and are warning other civilizations to avoid their mistakes. The message might encode information about existential risks, dangerous technologies, hostile alien species, or universe-scale threats that we haven't yet identified. Our inability to decode the message might be the tragedy. We can recognize that someone is screaming across the cosmos, but we cannot understand what they're screaming about. This interpretation gained disturbing support from additional signal discoveries. In December 2024, 13 months after the original detection, Dr. Sarah Chen's team at the Square Kilometer Array identified a second signal, this one originating from 6.8 billion light-years away. Like the first signal, it shows perfect coherence, impossible energy output, and embedded physical constants. But its structure is different. The second signal has a pulse duration of 2.1 milliseconds, repeats every 27.3 minutes, and contains 892 sub-pulses per pulse. The timing parameters don't match the first signal, but the fundamental physics of transmission is identical. In January 2025, a third signal was detected by the ALMA array in Chile, originating from 5.5 billion light-years away. In February, a fourth signal. By May 2025, astronomers had identified 17 distinct signals, all sharing the same impossible properties, but originating from different locations in the observable universe. The signals are not communicating with each other as far as we can tell. They're too far apart for light-speed communication to have occurred. They appear to be independent transmissions from different sources, all broadcasting into the void using the same fundamental technology. The discovery of multiple signals transformed the phenomenon from an isolated anomaly into a pattern requiring explanation. Dr. Liu Wei, the Chinese physicist who earlier warned against responding to the signals, published an updated analysis in Science in June 2025, arguing that the multiplicity of signals suggests we're detecting what he calls a, quote, galactic commons network, a communication infrastructure used by advanced civilizations across the universe. In this model, the signals are not messages directed at primitive species like us. They're maintenance transmissions, beacons, or possibly even conversations between civilizations using a technology we barely detect and cannot comprehend. The fact that we can detect them at all might be incidental, like ants detecting the vibrations from a subway system without understanding that the vibrations carry thousands of passengers or serve any transportation purpose. We perceive the signals as mysterious and impossible because we're not the intended audience. This revelation forced a psychological reckoning within the scientific community. For decades, humanity has implicitly assumed that while we might not be alone in the universe, we are at least qualified participants in cosmic affairs. The signals suggest otherwise. They indicate that we exist in a universe where civilizations vastly more advanced than us are conducting activities we cannot understand, using technology that appears to violate natural law for purposes we cannot fathom. We are not players in the cosmic game. We are barely sentient enough to notice that a game is being played. This realization has philosophical implications that extend beyond science into questions of meaning and purpose. If humanity's ultimate technological achievement is to become marginally aware of civilizations whose capabilities exceed ours by incomprehensible margins, what does that say about our significance? Are we important at all in the cosmic scheme? Or are we simply one more species of slightly clever apes who happen to develop radios just in time to detect the incomprehensible communications of our betters? The psychological impact of the signals' multiplicity cannot be overstated. Dr. Rebecca Torres, a psychologist at Stanford specializing in existential risk perception, conducted surveys of astronomers and physicists working on signal analysis. Her findings, published in Psychological Science in July 2025, revealed that approximately 40% of researchers involved in the project reported symptoms of what she termed cosmic insignificance syndrome: depression, anxiety, difficulty finding meaning in daily activities, and intrusive thoughts about humanity's irrelevance. These are trained scientists, people who already intellectually understood that Earth is a tiny speck in an incomprehensibly vast universe. But intellectual understanding and emotional confrontation are different experiences. The signals forced researchers to confront not just humanity's physical smallness, but our intellectual and technological inadequacy. We are children overhearing adult conversations, understanding only that we don't understand. The crisis deepened when further analysis revealed temporal patterns in the signals. Discovery. Dr. Chen's team reviewed their archival data and made a disturbing discovery. The first signal had actually been present in their data for 3 years before anyone noticed it. The square kilometer array had recorded the transmission since 2020, but it was buried in petabytes of survey data that no human had examined in detail. The signal was only identified in 2023 when improved analysis algorithms flagged it as anomalous. This raised the question, how many other signals are in our data that we haven't noticed? Dr. Marcus Webb at Oxford organized an international collaboration to reprocess radio telescope archival data from the past 20 years using the new analysis techniques. The project, dubbed Hidden Signals Initiative, published preliminary results in Nature in September 2025. They found 43 additional candidate signals showing similar properties to the confirmed detections. 43. Not all candidates have been confirmed yet. Verification requires sustained observation to rule out instrumental artifacts, but early indications suggest that at least 30 of them are real. The implications are staggering. If verified, it means the universe is flooded with these transmissions. They're not rare, they're not even uncommon. They're everywhere, filling the radio spectrum with conversations we've been too primitive to notice. Dr. Jill Tarter's essay about Type 4 civilizations suddenly seemed not speculative but conservative. The universe isn't empty, it's screaming with activity. We've been living in cosmic silence only because we lacked ears to hear. The discovery of pervasive signals created a secondary crisis in cosmology. If these transmissions are common, they represent a significant source of electromagnetic energy in the universe that has never been accounted for in cosmological models. Dr. Priya Sharma at Caltech calculated that if similar signals exist throughout the observable universe at the density implied by current detections, they collectively contribute approximately 0.001% of the universe's total electromagnetic energy budget. This sounds negligible, but in cosmology, every energy source matters. Dark energy, the mysterious force driving cosmic acceleration, makes up about 68% of the universe's energy content, but it was completely unknown until 1998. An unaccounted for energy source, even a small one, could affect calculations of cosmic expansion, structure formation, and the universe's ultimate fate. More disturbing was the realization that these signals have been propagating through space for billions of years, meaning they've been present throughout the entire history of the universe as we observe it. When cosmologists study distant galaxies and quasars, they're observing light that traveled through space filled with these coherent transmissions. The signals represent a form of electromagnetic pollution that has subtly affected every observation ever made in radio astronomy. Dr. Robert Cheng at JPL published calculations in the Astrophysical Journal in November 2025, showing that the signal's collective presence creates what he called coherent foreground contamination that has systematically biased measurements of the cosmic microwave background radiation, the faint afterglow of the Big Bang. The effect is small, less than a microkelvin in temperature measurements, but it's present. Every precise cosmological measurement we've made for decades has been contaminated by alien transmissions we didn't know existed. This contamination forced a reanalysis of fundamental cosmological data. The Planck satellite, which operated from 2009 to 2013, produced the most precise map ever made of the cosmic microwave background. That map forms the foundation of modern cosmology, constraining parameters like the universe's age, composition, and expansion rate. If the map is contaminated by coherent signals, those constraints might be wrong. Dr. Hassan al-Rashid at Cambridge led a collaboration to reprocess Planck data while filtering out the signal contamination. The preliminary results, published in Physical Review Letters in January 2026, showed that removing signal contamination altered the derived cosmological parameters by approximately 0.3%. This is small but significant. The universe appears to be about 50 million years older than previously calculated. Dark matter makes up about 0.5% more of the total energy budget, and the cosmological constant, dark energy's strength, is about 0.8% weaker. These adjustments are within previous uncertainty margins, but they represent systematic errors in the most precise measurements ever made of cosmic parameters. Our understanding of the universe has been subtly wrong because we didn't account for alien technology filling space with electromagnetic noise. The discovery of signal contamination in cosmological data led to another disturbing realization. If these signals affect our observations, they might be intentionally designed to do so. Dr. Avi Loeb at Harvard expanded on this idea in a paper published in Classical and Quantum Gravity in February 2026. Loeb proposed what he called the anthropic transmission hypothesis. The signals might be deliberately designed to contaminate the cosmic microwave background in ways that affect the development of emerging civilizations. The cosmic microwave background is often the first precision cosmological data that technological species can obtain. It requires only radio telescopes and doesn't depend on understanding complex astrophysics. A civilization looking to influence developing species might embed information or directives in the cosmic microwave background by adding coherent signals that appear as subtle temperature fluctuations. When we study the CMB, we think we're seeing the pristine afterglow of creation, but we might actually be reading a message that was placed there for us to find. Loeb's hypothesis is untestable with current technology, but it raises profound questions about epistemology. How do we know that any of our observations are untainted by deliberate manipulation? If civilizations exist with the power to create signals that propagate across billions of light years, they might also have the power to manipulate what we see when we look at the universe. The night sky might be an illusion, a constructed narrative designed to lead us toward particular conclusions or away from dangerous knowledge. This veers into paranoia, but it's paranoia grounded in demonstrated capabilities. We know these civilizations can create effects that appear to violate physics. If they can do that, what else can they do? The trustworthiness of observation, the foundation of science, becomes questionable when you're dealing with entities whose technology is indistinguishable from magic. The signal analysis community fractured into competing schools of interpretation. The naturalist faction, led by Dr. Philip Morrison at Harvard, maintains that the signals must have natural explanations within extended physics that we haven't yet discovered. They argue that invoking alien technology is premature and that history shows natural explanations usually prove correct given sufficient time and data. The technosignature faction, led by Dr. Avi Loeb and Dr. Sarah Chen, argues that the signals' properties definitively rule out natural origins and that accepting alien technology as the explanation is simply following the evidence. A third faction, the agnostics, led by Dr. Kip Thorne, maintains that we lack sufficient data to distinguish between advanced natural phenomena and alien technology, and that these might not even be distinct categories at the level of sophistication we're observing. The debate became heated at the International Astronomical Union General Assembly in August 2026, where the signal detections were the dominant topic. Dr. Morrison presented an extensive analysis arguing that the signals might represent a previously unknown state of matter called, quote, coherent plasma filaments that form in the intergalactic medium under specific conditions. His model proposes that when plasma reaches certain critical densities and temperatures while threading through large-scale magnetic fields, it can enter a coherent state similar to a laser or a Bose-Einstein condensate, producing the observed perfectly coherent transmissions. Morrison's model requires conditions that have never been observed in nature and makes predictions that cannot currently be tested, but it has the virtue of not requiring alien technology. Dr. Loeb responded by pointing out that Morrison's coherent plasma filaments would require fine-tuning of parameters to 1 part in 10 to the power of 12 to produce the observed signal properties, making them statistically equivalent to miraculous. At some point, Loeb argued, a natural explanation that requires such extreme fine-tuning is less plausible than simply accepting that we're seeing engineering. The debate deadlocked on a fundamental question: what counts as a sufficient explanation? In normal science, Natural phenomena are explained when we identify the physical mechanisms producing them and can reproduce those mechanisms experimentally or in simulations. But the signals operate at energy scales and across distance scales that we cannot reproduce in laboratories or simulations. We can observe them, but we cannot test hypotheses about their origins experimentally. This places signal studies in a unique epistemic category, similar to cosmology itself, where we have one universe to observe and cannot run controlled experiments. But cosmology studies the universe's large-scale properties, which we trust are governed by physical laws we can test locally. The signals appear to violate those laws, placing them outside the domain where standard scientific methodology reliably applies. This methodological crisis has implications beyond the specific question of signal origins. Dr. Rebecca Torres, the psychologist who documented cosmic insignificance syndrome, published a follow-up study in December 2026 examining how the signals affected scientists' understanding of their own discipline. She found that approximately 60% of surveyed physicists and astronomers reported that the signals had made them question fundamental assumptions of the scientific method. If observable phenomena can violate known physics, how do we decide which physics to trust? If natural and technological explanations become indistinguishable at sufficient scales of advancement, what does it mean to understand something scientifically? These questions don't have clear answers, and the resulting uncertainty has created an intellectual crisis in fields that previously considered themselves foundational and secure. The inability to decode the signals, information content remained the most frustrating aspect of the phenomenon. Dr. Lisa Mendoza at MIT organized an international collaboration called the Signal Decoding Initiative, bringing together cryptographers, linguists, mathematicians, and computer scientists to attack the problem. The initiative's first major publication, released in Nature Communications in March 2027, documented their failure in exhaustive detail. The team applied every decoding technique known to humanity: frequency analysis, pattern matching, Bayesian inference, machine learning, quantum computing algorithms, and approaches based on fundamental mathematics like prime numbers and physical constants. Nothing worked. The information in the signals remains opaque. Mendoza's paper concluded with a sobering assessment. The information content is demonstrably present. Entropy analysis confirms this. The structure is non-random. Statistical tests verify this. But the symbolic system encoding the information bears no relationship to any human framework for organizing knowledge. We cannot read the message because we lack the conceptual categories necessary to understand what kind of message it is. This failure led some researchers to question whether the signals contain information at all in any sense we would recognize. Dr. Yuki Tanaka at the University of Tokyo proposed an alternative interpretation in a controversial paper published in Foundations of Physics in May 2027. Tanaka argues that what we interpret as information might actually be computational processes. The signals might not be transmitting data, but performing calculations, using the electromagnetic field itself as a distributed computer. In this model, the coherence we observe results from the calculation requiring perfect phase relationships to function correctly. The energy output represents computational power rather than transmitted power. The mathematical structure we detect is not a message, but the intermediate steps of an incomprehensibly complex calculation being performed across cosmic distances. Tanaka's model explains why we cannot decode the signals. There's nothing to decode. We're seeing the computational substrate, not the results of the computation. If Tanaka is correct, the implications are extraordinary. It would mean that these civilizations use space itself as a medium for computation, treating the electromagnetic field as a vast, distributed processor. The entire universe might be permeated with ongoing calculations, computations so complex that they require billions of light-years of space to execute. What could possibly require such enormous computational resources? Dr. Lee Smolin at Perimeter Institute suggested one possibility. The civilizations might be simulating entire universes, running computational models of reality so detailed that they require universe-scale computers to execute. Another possibility, proposed by Dr. David Chalmers at New York University in a philosophical paper published in Mind in August 2027, is that the civilizations are not just using the universe as a computer, but discovering that the universe is a computer, that physical reality is fundamentally computational, and they're tapping into the underlying processing substrate that makes existence itself possible. These ideas pushed beyond science into metaphysics, but the signals themselves forced this boundary crossing. When observed phenomena exceed known physics by orders of magnitude, and when standard scientific explanations fail repeatedly, researchers have no choice but to consider possibilities that would normally be dismissed as speculation. The signals became a Rorschach test onto which different researchers projected different interpretations based on their prior philosophical commitments. Materialists saw exotic natural phenomena. SETI enthusiasts saw alien communication. Information theorists saw distributed computation. Simulation hypothesis proponents saw evidence that reality is computational. Each interpretation had some support from the data, but none could be definitively proven or disproven. The signals remained stubbornly ambiguous, compatible with multiple incompatible explanations. The proliferation of signals presented another puzzle. Why are they all similar in their fundamental physics, but different in their specific parameters? The 17 confirmed signals as of mid-2027 all show perfect coherence, impossible energy output, and embedded physical constants. But their pulse durations range from 1.8 to 4.1 milliseconds, their repetition periods from 12 to 35 minutes, and their subpulse counts from 2,048 to 16,384. These differences seem deliberate, as if each signal is individually designed rather than following a universal template. Dr. Carl DeMarco at Princeton analyzed the parameter variations in a paper published in Statistical Science in October 2027. He found that the parameters are not randomly distributed but follow power law relationships. The pulse durations are all expressible as simple fractions of the repetition periods. The subpulse counts are all powers of 2. The energy outputs, while varying by factors of 3 to 5 between different signals, all fall within a narrow band when corrected for distance and intervening matter density. DeMarco interpreted these regularities as evidence that the signals originate from a coordinated network following common engineering standards. Just as human radio transmitters operate on assigned frequency bands to avoid interference, the alien transmitters might be using standardized timing parameters to prevent their signals from overlapping in ways that would complicate detection or processing. This interpretation treats the signals as parts of a single technological infrastructure, rather than independent transmissions from unrelated civilizations. It suggests a level of coordination across billions of light years that implies faster-than-light communication or extraordinary long-term planning. If the signals are coordinated, someone or something is managing a communication network that spans most of the observable universe. The logistics of such an undertaking exceed human imagination. The administrative structure alone would need to operate across timescales of billions of years, maintaining consistency and standards while stars are born and die, while galaxies collide and merge, while the universe itself evolves and expands. An alternative interpretation came from Dr. Jessica Park at Lawrence Livermore, who proposed in a paper published in Complexity in January 2028 that the signals' parameter variations result from different civilizations independently discovering the same fundamental technology but implementing it with local variations. In this model, the underlying physics of coherent transmission is universal. There's one correct way to create signals that maintain coherence across cosmic distances, but the specific implementation details vary based on each civilization's technological history and cultural preferences. This is similar to how humans and hypothetical aliens might both discover radio transmission through Maxwell's equations, but build different types of transmitters based on available materials and engineering traditions. Park's model treats the signals as convergent evolution in technology, multiple species independently arriving at similar solutions to the same fundamental problem. Both interpretations, coordinated network versus convergent evolution, have profound implications. The coordinated network model suggests that advanced civilizations cooperate on scales and timescales that dwarf human political structures, maintaining stability and communication across billions of years. This implies a level of societal maturity and long-term thinking that humanity has never achieved. Our longest-lasting institutions, like certain religions or the Chinese imperial system, persisted for a few thousand years. We cannot maintain political stability across centuries, let alone eons. The existence of a billion-year-old communication network implies that the civilizations operating it have solved every problem that causes collapse. Resource conflicts, ideological differences, technological disasters, Internal decay. They have achieved something approaching permanence, becoming features of the cosmic landscape as enduring as stars. The convergent evolution model is equally sobering, but in a different way. If multiple civilizations independently develop this technology, it suggests that there's a natural progression in technological development that leads toward these capabilities. It implies that our own future, if we survive long enough, might inevitably lead us to become signal transmitters ourselves. This raises the question, why haven't we detected signals from civilizations at our level or slightly beyond us? Why only detect signals from entities so advanced that their technology appears magical? One possible answer is selection bias. Signals from civilizations at our level would be too weak to detect across interstellar distances. We can only detect transmissions from civilizations that have mastered the physics of coherent cosmic-scale communication. This means the universe might be filled with civilizations at every level of development, but we can only perceive the most advanced ones, the technological equivalent of only being able to see the brightest stars while countless dimmer stars remain invisible. The signal's discovery coincided with a broader crisis in humanity's relationship with technology. By 2027, artificial intelligence had progressed to the point where machine learning systems routinely solved problems that human researchers could not, operating through mechanisms their designers didn't fully understand. Autonomous weapon systems made kill decisions without human oversight. Financial markets were dominated by algorithmic trading so complex that no human could track or predict its behavior. The traditional model of technology as a tool controlled by human intelligence was breaking down. Technology was becoming autonomous, pursuing goals and using methods that exceeded human comprehension. The signals represented an endpoint of this trajectory. Technology so advanced that it's indistinguishable from natural phenomena, operating according to principles that its creators might not even fully understand anymore, pursuing goals that might have been forgotten billions of years ago. The transmitters might still be broadcasting because they were told to billions of years past, and no one ever told them to stop. They might be the fossil remains of long-dead civilizations, automated systems continuing to execute their programming long after their creators disappeared. This idea that the signals might be technological fossils gained support from an unexpected source. Dr. Martin Rees, the British Astronomer Royal, published a short but influential essay in Scientific American in March 2028, titled, "Are We Listening to Ghosts?" Rees argued that the signal's extreme stability and perfect consistency with physical constants measured 4.2 billion years ago suggests they're not actively maintained, but rather extremely robust automatic systems that have operated without intervention for eons. A living civilization maintaining these transmitters would presumably update them occasionally, incorporating new scientific knowledge or adjusting parameters as physics understanding improved. The signals show no evidence of evolution or modification. They appear frozen in time, broadcasting the same patterns with the same precision across billions of years. This temporal rigidity suggests automation rather than active management, machines faithfully executing ancient instructions while the civilizations that built them have long since moved on or died out. The ghost hypothesis created a new form of cosmic melancholy among researchers. The idea that we're detecting signals from extinct civilizations, that the universe is a graveyard filled with the automated systems of the dead, struck many as profoundly sad. Dr. Rebecca Torres documented this in a third psychological study published in June 2028, identifying what she called temporal alienation, the feeling that humanity exists in the wrong era, either too late to meet the great civilizations of the past or too early to join the communities of the future. The signals provided evidence that the universe once hosted civilizations of incomprehensible power and sophistication, but also evidence that those civilizations are likely gone. We're alone in space, but also alone in time, separated from potential peers by billions of years of cosmic history. We will never meet the beings who created these signals. They died before our sun was born. Their technology outlived them, broadcasting into the void long after their extinction, waiting for someone to hear. But the ghost hypothesis faced challenges from ongoing signal monitoring. Dr. Sarah Chen's team at the Square Kilometre Array had now tracked the original signal continuously for over 4 years. In July 2028, they detected something new, a microscopic variation in the signal's timing. The pulse duration, previously stable to 15 decimal places, had changed by approximately 3.2 nanoseconds. This is an incomprehensibly small variation, 3/1000th of a second in a pulse lasting 3.7 milliseconds, but it was definitely real, confirmed by multiple independent measurements. More disturbingly, the variation appeared to be systematic, rather than random. Over the following 6 months, the pulse duration continued to decrease at a rate of approximately 0.8 nanoseconds per month. Something about the signal was changing, slowly but measurably. The discovery of temporal variation in the signal disproved the complete automation hypothesis. If the signal were simply an ancient machine operating on fixed programming, it would not be modifying its parameters. The variation suggests active control, ongoing management by some intelligence that monitors the transmission and adjusts it for purposes we cannot determine. Dr. Lisa Mendoza proposed several possible explanations in a rapid publication paper in Astrophysical Journal Letters in January 2029. The variation might be a deliberate modulation carrying information at timescales of months to years. It might be a response to detected observers. The signal's operators might have noticed our observations and are now modifying their transmission to communicate with us. Or it might be an artifact of the transmission process itself, some aspect of the coherence maintenance mechanism that produces slow drifts in timing parameters. The third explanation proved correct when Dr. Yuki Tanaka at Tokyo University discovered that the signal's pulse duration variation correlated perfectly with changes in the density of the intergalactic medium along the line of sight between Earth and the signal's source. As galaxies slowly move and evolve, the distribution of matter in space changes. These changes alter the propagation environment for electromagnetic radiation. The signal's pulse duration adjustments appear to be compensating for these environmental changes, maintaining perfect coherence despite slowly varying conditions in the transmission medium. This proved beyond any doubt that the signal is actively managed. Something is constantly monitoring the 4.2 billion light-year path between the source and, somewhere, adjusting transmission parameters to compensate for changes in the intervening medium. The technical sophistication required for such real-time adjustment across cosmic distances exceeds human engineering by margins that render comparison meaningless. The active management discovery raised a disturbing question. Are the signals directed at us specifically, or are we incidentally detecting transmissions aimed elsewhere? Dr. Robert Chang at JPL analyzed the geometry of all confirmed signals in a paper published in Astrobiology in April 2029. He found that the signals are not distributed randomly across the sky. They show a weak but statistically significant clustering pattern, with most signals originating from a region roughly aligned with the direction of the Virgo supercluster, a massive gravitational structure containing tens of thousands of galaxies located about 65 million light-years from Earth. This alignment is unlikely to be coincidental. The signals might all be transmitting toward or from the Virgo supercluster, with Earth simply lying along one of the transmission paths. We're not the intended recipients. We're eavesdropping on communications passing through our neighborhood on their way elsewhere. This interpretation has significant implications. If the signals are not directed at us, there's no reason to expect we'll ever decode them. The encoding might be optimized for receivers who already understand the symbolic system being used, with no attempt to make the transmission comprehensible to unknown observers. It would be like listening to encrypted radio traffic. You can detect the transmission, you can measure its properties, but you cannot extract its meaning without the decryption keys. This would explain why every decoding attempt has failed. The signals aren't designed to be decoded by outsiders. They're designed for efficient communication between parties who already share a common framework. But the clustering toward Virgo raised another possibility. Perhaps the Virgo supercluster hosts an extraordinary concentration of advanced civilizations, a galactic-scale metropolis where the denizens of thousands of galaxies have achieved communication and coordination. From this perspective, our local region, the Milky Way and its satellite galaxies, exists in cosmic backwater, far from the centers of galactic civilization. The signals we detect are long-distance transmissions between the Virgo metropolis and outlying regions, crossing our isolated corner of space on their way to distant destinations. We're seeing evidence of civilizations communicating across the universe while we sit in provincial isolation, too primitive to participate. This interpretation led to renewed interest in examining the Virgo supercluster itself for signs of unusual activity. Dr. Marcus Webb at Oxford organized an observing campaign using multiple space-based telescopes, Hubble, James Webb, Chandra X-ray Observatory, to conduct detailed surveys of galaxies in Virgo. The results, published in Nature Astronomy in September 2029, were simultaneously fascinating and frustrating. The Virgo galaxies appear completely normal. They show the expected populations of stars, the expected rates of star formation, the expected distributions of gas and dust. There is no evidence of massive engineering projects, no Dyson spheres surrounding stars, no artificial structures visible at galactic scales. If the Virgo supercluster hosts thousands of advanced civilizations, they're either hiding perfectly or conducting their activities at scales or in dimensions we cannot observe. The signals prove that advanced civilizations exist and are active, but optical and infrared telescopes reveal nothing unusual. Whatever these civilizations are doing, they're doing it without leaving visible traces. The failure to detect visible artifacts led to a theoretical breakthrough by Dr. Hiroshi Nakamura at Kyoto University. In a paper published in Physical Review D in December 2029, Nakamura proposed that advanced civilizations deliberately minimize their observable footprint to avoid what he called cosmic predation. In Nakamura's model, the universe contains technological species at many different levels of advancement, and the most advanced species pose existential threats to less advanced ones. A civilization that announces its presence through visible megastructures or careless energy expenditure risks attracting the attention of more advanced civilizations that might view them as threats or resources. Survival, therefore, requires stealth, conducting technological activities in ways that leave minimal observable signatures. The signals we detect might represent the bare minimum communication necessary to maintain coordination across the civilization's network, with all other activities deliberately hidden. This idea connected to the dark forest hypothesis proposed by Chinese science fiction author Liu Cixin, which suggests that the universe is filled with civilizations all hiding from each other because first contact between species at different technological levels inevitably results in the extinction of the weaker species. Nakamura's contribution was to provide a physical mechanism for how such hiding works at the level of advanced technology. If you can manipulate the quantum vacuum, engineer spacetime and perform computations using exotic physics, you can conduct all your activities in ways that appear as natural phenomena or remain completely invisible to less advanced observers. The signals are visible only because maintaining coherent transmission across cosmic distances requires manipulating electromagnetic fields in ways that cannot be completely hidden. Everything else these civilizations do might be occurring in domains we cannot access or observe. The dark forest implications terrified some researchers and policymakers. If merely detecting these signals puts humanity at risk by announcing our presence to potential predators, should we be broadcasting our existence? The question had been debated in SETI circles for decades, but it took on new urgency with evidence that the universe contains civilizations whose capabilities exceed ours by literally incomprehensible margins. Dr. Liu Wei, who had warned about responding to the signals from the beginning, organized a conference in Beijing in March 2030, bringing together scientists, military strategists, and government officials to discuss humanity's response protocols. The conference proceedings, published as a special issue of Acta Astronautica in July 2030, revealed deep disagreement about basic strategy. One faction, led by Dr. Avi Loeb, argued that humanity should actively attempt to communicate with the signal sources, transmitting messages that demonstrate our technological sophistication and peaceful intentions. Loeb argued that the alternative, cowering in silence while knowing we've been detected, is both futile and undignified. If these civilizations can create the signals we've detected, they can certainly detect our radio and television broadcasts that have been propagating outward from Earth for a century. Hiding is not an option. We can only choose whether to remain passive listeners or become active participants in cosmic communication. The faction advocating communication proposed several response strategies: transmitting mathematical proofs, encoding information about human biochemistry and culture, directing powerful radio transmissions toward the signal sources and toward the Virgo supercluster. The goal would be to establish a dialogue, or at least demonstrate that humanity is sapient and deserves consideration. The opposing faction, led by Dr. Liu Wei and supported by military advisors from multiple countries, argued that any communication attempt is catastrophically dangerous. We don't know these civilizations' intentions, we don't know how they would respond to contact from a primitive species, and we don't know if drawing their attention might trigger predatory or defensive responses. The only safe strategy is silence. Continue monitoring the signals, work to decode them, but transmit nothing that could identify Earth's location or humanity's capabilities. This faction pointed to Earth's own history, where first contact between technological civilizations, European colonizers encountering indigenous peoples, generally resulted in devastation for the less advanced culture. There's no reason to expect cosmic first contact would be any different. An advanced civilization might view humanity as interesting, as useful, or as irrelevant, but there's no guarantee they would view us as worth preserving. The debate remained unresolved, but in practice, the silence faction won by default. No government or organization possessed both the resources and the will to initiate active communication. The Square Kilometer Array and other facilities continued their role as passive observers, monitoring the signals while humanity remained silent. This felt like cowardice to some researchers and prudence to others, but it reflected a broader paralysis in dealing with phenomena that exceeded human frameworks for understanding and responding to the universe. The signals continued to accumulate. By August 2030, the total count of confirmed detections had reached 67, with another 100 candidates awaiting verification. The Hidden Signals Initiative reprocessing of archival data had revealed that signals had been present in human observation since the 1960s, buried in data from early radio astronomy surveys that lacked the sensitivity and analysis capabilities to identify them. The universe had been screaming at us for decades. We simply couldn't hear it. Dr. Sarah Chen estimated in an interview with Nature in October 2030 that at the current rate of discovery and verification, the total number of detectable signals might reach several hundred within 5 years, possibly exceeding 1,000 within a decade. The signals were not rare anomalies, but a pervasive feature of the radio universe, an electromagnetic ecology that had existed since before humans evolved, surrounding us, penetrating us, carrying information we could not decode about civilizations we could never meet. The multiplicity of signals enabled new types of analysis. Dr. Priya Sharma at Caltech led a team that compared signal properties across all confirmed detections, looking for patterns that might reveal the underlying physics or engineering principles. Their results, published in Science in February 2031, identified several remarkable regularities. First, every signal's energy output, when corrected for distance and intervening matter, falls within a range of exactly 1 order of magnitude. The most powerful signal is only 10 times more energetic than the weakest. This narrow range suggests the signals are all produced using the same fundamental technology operating near the same efficiency limits. Second, the signal's carrier frequencies, while centered on the hydrogen line, show small systematic variations that correlate with the age of their source galaxies. Signals from older galaxies broadcast at slightly lower frequencies, while signals from younger galaxies broadcast at slightly higher frequencies. The correlation is weak but statistically significant, suggesting that the transmission technology has evolved over cosmic time, with newer implementations using slightly different frequency optimization. Third, and most intriguingly, Sharma's team found that the signals showed correlated timing variations when examined at timescales of years to decades. If one signal's pulse rate increased, other signals tended to show similar increases months to years later. The correlations were weak and noisy, but they existed. This suggested that the signals are not independent but respond to some shared environmental factor or coordinate their activities through mechanisms unknown. Dr. Yuki Tanaka proposed that the timing correlations result from variations in dark energy density, affecting the quantum vacuum properties that allow coherent transmission. If dark energy fluctuates on large scales across cosmic time, it might alter the propagation characteristics of coherent signals, forcing all transmitters to adjust their parameters simultaneously to maintain signal quality. This would explain the correlations while also providing the first observational evidence that dark energy is not perfectly constant but fluctuates on timescales of years to decades. The dark energy connection led to an unexpected development. Dr. Adam Riess at Johns Hopkins, who shared the Nobel Prize for discovering cosmic acceleration in 1998, became interested in using the signals as a probe of dark energy properties. Riess proposed in a paper published in the Astrophysical Journal in June 2031 that the signal's extraordinary coherence makes them sensitive to any variations in the expansion rate of the universe along their propagation path. By measuring precise timing variations in signals from different distances, researchers could map how dark energy's strength has changed across cosmic history with unprecedented precision. The signals, despite being impossible to explain, might become tools for understanding one of cosmology's deepest mysteries. This represented a strange inversion. Using artifacts we don't understand to study physical phenomena we also don't understand, hoping that the combination yields insight into both. Rees organized a collaboration called the Cosmic Chronometry Project to implement this idea. The project's first results, released in January 2032, were stunning. By analyzing timing variations in 43 signals at distances ranging from 2 to 8 billion light-years, the team reconstructed the universe's expansion history across the past 8 billion years with precision exceeding all previous measurements. They confirmed that cosmic expansion is accelerating, but discovered that the acceleration rate itself is not constant. Dark energy appears to be getting stronger over time, causing the universe's expansion to accelerate at an increasing rate. This superacceleration was unexpected and has profound implications for the universe's ultimate fate. If dark energy continues strengthening, the universe won't just expand forever, it will tear itself apart. First, galaxy clusters will be ripped apart as dark energy overcomes their gravitational binding. Then galaxies themselves will fragment. Eventually, stellar systems will disintegrate, planets will be stripped from their orbits, and in the final stages, atoms themselves might be shredded by the exponentially increasing expansion. This catastrophic end is called the Big Rip, and the signal-based measurements suggested it might occur approximately 120 billion years from now. The Big Rip prediction created public panic when news outlets reported it in sensationalized terms. Headlines screamed about universe doomed to tear apart and 120 billion year countdown to cosmic death. Astronomers attempted to provide context. 120 billion years is incomprehensibly distant. Earth and the Sun will be long dead from natural stellar evolution billions of years before the Big Rip becomes relevant, but the psychological impact was significant. Dr. Rebecca Torres published her fourth major study on the signal's psychological effects in July 2032. Documenting what she termed eschatological anxiety, fear and despair arising from awareness of the universe's eventual fate. Even though the Big Rip's timescale rendered it cosmically irrelevant to any individual or civilization, knowing that reality itself has an expiration date created existential distress for many people. The eschatological anxiety merged with earlier cosmic insignificance syndrome to create what Torres described as a, quote, crisis of cosmic meaning. If the universe is filled with incomprehensibly advanced civilizations that we cannot communicate with, and if the universe itself is doomed to eventual destruction that will erase all achievements and all structures, what is the point of human striving? Why build civilizations, create art, pursue science, or care about anything when cosmic forces beyond our comprehension or control will ultimately render everything meaningless? These questions are not new. Philosophers and theologians have grappled with mortality and meaninglessness for millennia. But the signals made them concrete and inescapable. The universe's indifference to humanity was no longer a philosophical abstraction, but an empirical fact, demonstrated by transmissions that crossed billions of light-years without any consideration of whether humans would exist to receive them. Some researchers and public intellectuals responded to the crisis by arguing for a new form of cosmic humility. Dr. Martin Rees published a book in September 2032 titled Our Place in the Universe, Accepting Cosmic Insignificance, arguing that the signals should liberate rather than devastate us. If we're truly insignificant on cosmic scales, then our achievements need not be measured against cosmic standards. Human meaning can be local, confined to our world and our moment in time, without needing to resonate across the universe or survive until the end of time. We can find purpose in connection with each other, in creation for its own sake, in the pursuit of understanding, even if that understanding is forever incomplete. Rees argued that accepting our insignificance is actually freeing. It removes the burden of cosmic importance and allows us to define our own meaning rather than searching for meaning ordained by the universe. Others found this perspective unsatisfying. Dr. Avi Loeb published a counterargument in January 2033 titled Cosmic Ambition: Why We Should Strive to Matter, arguing that the signals prove advanced civilization is possible and that humanity should aspire to become similarly advanced rather than accepting permanent insignificance. If others have mastered physics to the point of apparent law violation, so can we. The gap between current humanity and the signal-producing civilizations is vast but not necessarily unbridgeable. We've progressed from pre-industrial to technological civilization in a few centuries. Give us a few millennia or a few million years, and we might develop capabilities that currently seem impossible. Loeb argued that the appropriate response to discovering more advanced civilizations is not despair but determination, a commitment to advancement, to long-term survival, to becoming worthy of participation in cosmic affairs rather than remaining eternal observers on the sidelines. The debate between cosmic humility and cosmic ambition played out across academic publications, popular books, and public discourse throughout 2033 and 2034. It represented a fundamental disagreement about how humanity should respond to evidence of our cosmic context. But while philosophers debated meaning, researchers continued extracting information from the signals themselves. Dr. Lisa Mendoza's signal decoding initiative, despite failing to crack the signal's informational content, made progress in understanding their mathematical structure. In a major publication in Communications of the ACM in March 2034, Mendoza's team demonstrated that the signal's fractal encoding operates across at least 12 hierarchical levels. From nanosecond subpulses up to year-scale timing variations. Each hierarchical level contains approximately the same amount of information entropy, suggesting that the encoding scheme distributes information across scales to provide redundancy and error correction. More remarkably, the team discovered that the fractal structure itself contains meta-information, information about the information. Embedded in the pattern of how information is distributed across hierarchical scales are what appear to be pointers or indices, analogous to a table of contents in a book. These indices don't tell us what the signal says, but they tell us how the signal is organized. Mendoza's team identified 17 distinct index patterns repeating across different signals, suggesting that the transmissions follow standardized formatting conventions. This proved that the signals are indeed constructed messages rather than raw data streams, designed according to communication protocols that the senders share. The discovery moved understanding forward incrementally. We still couldn't read the messages, but we could now identify where different types of content were located within the transmission structure. Using this structural understanding, Dr. Carl DeMarco at Princeton attempted to identify signal components that might contain universally comprehensible information. His reasoning was that any communication from an advanced civilization to a less advanced one should contain a primer basic information designed to help recipients bootstrap their understanding of the encoding system. Human designs for interstellar messages like the Arecibo message or the Voyager Golden Record included primer sections showing how to interpret the encoding. DeMarco searched for signal components that showed lower complexity than the rest of the transmission, components that might be deliberately simplified to aid understanding. His results, published in SETI Research in August 2034, identified 13 signal components across multiple transmissions that showed this simplified structure. These components accounted for approximately 0.8% of the total information content, suggesting they might be primer sections. Decoding these simpler components became the Signal Decoding Initiative's primary focus for the next year. The team applied every analytical technique available, searching for patterns that matched fundamental mathematics, physical constants, or geometric relationships. In June 2035, they achieved a breakthrough. Dr. Aisha Patel, a mathematician at Oxford working with Mendoza's team, discovered that one of the simplified components could be interpreted as a geometric construction, a sequence of operations building up complex shapes from simple ones. The construction started with a point, extended it to a line, rotated the line to create a circle, combined circles to create spheres, and continued through increasingly complex geometric operations. The final result was a three-dimensional fractal structure with properties that matched the large-scale distribution of matter in the universe, the cosmic web of filaments and voids that galaxies inhabit. The geometric construction was published in Nature in August 2035 with the title, "First Successful Decoding of Extraterrestrial Signal Content." The paper was careful to note that they had decoded only a tiny fraction of one signal's content, and the decoded information was geometric rather than linguistic, but it represented genuine progress. More importantly, understanding the geometric construction provided a key for interpreting other signal components. If the primer sections taught geometric construction as a symbolic language, other parts of the signal might use geometry to encode information about physical structures, astrophysical phenomena, or even the civilizations themselves. The team began searching for additional geometric patterns in the signal's structure, hoping to expand their decoding capabilities. The decoding breakthrough changed the public and scientific conversation about the signals. They were no longer utterly incomprehensible mysteries, but partially comprehensible messages that humanity was slowly learning to read. This psychological shift was documented by Dr. Rebecca Torres in a study published in January 2036, showing that successful decoding, even of a tiny fragment, significantly reduced eschatological anxiety and cosmic insignificance syndrome among researchers. Understanding even a fragment of the signals made people feel less helpless, less excluded from cosmic affairs. We might never achieve parity with the civilizations that created these transmissions, but we could at least demonstrate the capacity to understand them. But the decoding also revealed something disturbing. The geometric construction in the primer section depicted the large-scale structure of the universe accurately, matching observations of the cosmic web. However, embedded within the structure were additional features that don't appear in our observations. Geometric elements representing structures or patterns that either don't exist in our region of the universe or exist but remain undetected. Dr. Aisha Patel's team identified 3 such anomalous features in their initial decoding. The first was a set of geometric transformations suggesting the existence of higher dimensional spaces connecting different regions of the conventional 3-dimensional cosmos. The second was a fractal pattern, implying that cosmic structure continues to smaller scales than we can observe, possibly indicating that dark matter has substructure we haven't detected. The third was the most disturbing, a geometric relationship suggesting that the visible universe is embedded within a larger structure that we cannot observe because it exists outside our cosmic horizon, the boundary beyond which light hasn't had time to reach us since the Big Bang. Each of these features, if real, represents knowledge about the universe that humanity hasn't acquired through observation. The signals might be teaching us about reality's structure, revealing aspects of the cosmos that we cannot detect with current technology or haven't yet recognized in our data. This created a dilemma for scientists. Should we trust information decoded from alien signals when it contradicts or extends beyond our empirical observations? The signals have proven reliable in encoding known physical constants accurately, suggesting their creators possess genuine knowledge about reality. But accepting their information without independent verification violates scientific methodology. We would be taking truth claims on authority rather than deriving them from observation and experiment. This tension between empirical verification and revealed knowledge forced uncomfortable questions about epistemology and the nature of scientific truth. Dr. Kip Thorne organized a workshop at Caltech in March 2036 to address these epistemological challenges. The workshop brought together physicists, philosophers of science, and information theorists to establish protocols for handling decoded information. The consensus that emerged, published as a white paper in Foundations of Physics in July 2036, proposed a 3-tier verification system. Tier 1 information, decoded content that matches existing human knowledge, should be accepted as confirmation of successful decoding. Tier 2 information, decoded content that makes predictions about observable phenomena humanity hasn't yet tested, should be treated as hypotheses requiring experimental verification before acceptance. Tier 3 information, decoded content about unobservable aspects of reality beyond our cosmic horizon or outside accessible energy scales, should be treated as potentially true but unverifiable speculation, useful for theoretical development but not accepted as established fact. This framework allowed researchers to work with decoded information without abandoning empirical standards, but it acknowledged that the signals might grant access to knowledge that cannot be independently verified. If the signal-producing civilizations have explored regions of space we cannot reach or conducted experiments at energy scales we cannot access, they possess empirical knowledge that is, from humanity's perspective, indistinguishable from revelation. We can choose to believe their claims based on their demonstrated reliability in areas we can verify, but we cannot confirm them through our own observations. This represents a new category of knowledge in science, something like testimony from trustworthy but inaccessible sources. It's closer to how humans treat historical testimony. We accept historians' accounts of past events we cannot directly observe because they've proven reliable in cases where verification is possible, than to how science traditionally operates through reproducible observation and experiment. The geometric primer decoding opened pathways for understanding other signal components, but progress remained slow. By the end of 2036, researchers had successfully interpreted approximately 2% of one signal's content, identifying geometric constructions depicting cosmic structure, fundamental particle relationships, and what appeared to be engineering diagrams for exotic technologies. Each decoded fragment required months of work by teams of specialists, and the complexity of the encoding increased dramatically in non-primer sections. The signals contained more information than humanity could analyze with current resources and techniques. Dr. Lisa Mendoza estimated that fully decoding a single signal would require centuries of sustained effort, possibly millennia, and there were now over 100 confirmed signals. The information content vastly exceeded humanity's capacity to process it. This realization led to proposals for developing AI systems specialized in signal analysis. If human researchers couldn't decode the signals in reasonable timescales, perhaps artificial intelligence could. Dr. Alan Zhang at DeepMind organized a collaboration with the Signal Decoding Initiative to develop machine learning systems trained on the partially decoded signal fragments. The project, called Signal Mind, began in January 2037 with the goal of creating AI that could learn the signals, symbolic language, and decode content without human intervention. Early results were promising. The AI systems identified geometric patterns that human researchers had missed and suggested interpretations for previously incomprehensible signal sections. But the approach also raised concerns. If we delegate understanding to AI systems that operate through mechanisms we don't comprehend, are we truly learning from the signals, or merely creating new black boxes that translate from one incomprehensible system to another? Dr. David Chalmers, the philosopher who had earlier written about the signals' implications for consciousness and computation, published an influential essay in Mind in June 2037 titled, "Can AI Understand What We Cannot?" Chalmers argued that using incomprehensible AI to decode incomprehensible alien signals creates a dangerous epistemological situation where humanity becomes dependent on interpretive systems we cannot verify. The AI might be correctly translating the signals, content, or it might be generating plausible-sounding interpretations that have no relationship to the signals' actual meaning. We would have no way to tell the difference. Chalmers advocated for what he called transparent decoding, approaches that maintain human understanding at every step, even if this makes progress slower. We should decode only what we can genuinely comprehend rather than achieving rapid progress through opaque automation. The debate over AI-assisted decoding became heated throughout 2037 and 2038, with some researchers arguing that speed is essential. The signals might contain warnings about existential threats or instructions for avoiding civilizational collapse, while others insisted that understanding, not speed, should be the priority. The debate remained unresolved when events overtook it in October 2038. Dr. Sarah Chen's team at the Square Kilometer Array detected a new signal unlike any previously observed. This signal, designated SIG-001A for its apparent connection to the original SIG-001 detection, originated from the exact same location as the first signal but used different transmission parameters. It broadcast at 840 MHz, twice the hydrogen line frequency, with a pulse duration of 1.85 milliseconds and a repetition rate of 9.09 minutes. Every parameter was exactly half the original signal's corresponding parameter. The harmonic relationship between SIG-001 and SIG-001A could not be coincidental. Something at the source had initiated a second transmission using precisely defined mathematical relationships to the first. Dr. Carl DeMarco analyzed the new signal structure in a rapid publication paper in Astrophysical Journal Letters in December 2038, demonstrating that SIG-001A contained geometric primer sections similar to SIG-001, but with additional complexity. The geometric constructions in SIG-001A included everything from SIG-001 plus new elements depicting what appeared to be causality diagrams, representations of how events influence each other across space and time. More disturbingly, the causality diagrams included features suggesting retrocausality or acausality, events that influence the past or exist outside normal causal relationships. If correctly interpreted, this information implied that the signal's creators understood causality at a level that allows manipulation of temporal relationships, possibly including time travel or access to timelines where cause and effect operate differently than in our observable universe. The appearance of SIG-001A triggered intense speculation about why a new signal had appeared now, 15 years after the original detection, and 4.2 billion years after the transmission originated. Dr. Lisa Mendoza proposed 3 possibilities in an analysis published in Science in February 2039. First, the new signal might have always been present but was previously undetected because researchers focused on hydrogen line frequencies. Second, the new signal might actually be a recently initiated transmission originating much closer to Earth than the 4.2 billion light-years of SIG-001, appearing to come from the same direction by coincidence. Third, and most unsettling, the new signal might be a response to humanity's detection of the original signal, transmitted across 4.2 billion light-years instantaneously using technology that allows faster-than-light or causal communication. Each explanation had troubling implications. The first suggested that humanity had missed major signal components through incomplete searches, implying that the full scope of the phenomena remained unknown. The second suggested extraordinary coincidences that strained credulity. The third implied that the signal's creators possessed technology that could violate relativity's light speed limit, allowing real-time communication across cosmic distances. If the third explanation was correct, it meant that the signals we detected over 15 years were only the most obvious detectable components of a communication network that operates primarily through channels we cannot observe. The coherent electromagnetic transmissions might be backup systems or legacy protocols maintained for compatibility with primitive civilizations that lack access to faster-than-light technology. The real conversations might be happening through tachyonic transmissions, wormhole networks, quantum-entangled channels, or mechanisms that physics hasn't conceived. Dr. Robert Chang at JPL organized a comprehensive search for faster-than-light signals in January 2039. Deploying resources to monitor quantum vacuum fluctuations, gravitational wave detectors, neutrino observatories, and exotic particle detectors for anomalous patterns that might represent FTL communication. The project, called Beyond Light, operated for 18 months without detecting anything unusual. If FTL communication existed, it remained invisible to humanity's instruments. But the absence of detection didn't prove absence. Advanced civilizations might use FTL technologies that interact so weakly with ordinary matter that our detectors cannot perceive them, or they might operate in dimensions or energy regimes we cannot access. The universe could be filled with FTL transmissions, and we would be completely oblivious. This possibility, that humanity is surrounded by communications we cannot detect using physics we don't understand, represented the final humiliation. We had progressed from thinking we were alone in the universe to discovering signals that proved we weren't alone, to realizing the signals came from civilizations incomprehensibly more advanced than us, to learning that these electromagnetic signals might be the primitive, archaic remnants of communication networks, while the real conversations happened through channels forever beyond our perception. We were not just primitive. We were so primitive that we could only detect the equivalent of smoke signals while laser communications, radio, the internet, and technologies we haven't imagined float around us undetected. Cosmic insignificance syndrome reached new depths. We weren't just small in physical scale. We were small in every dimension that mattered. Intellectually, technologically, perceptually, we were infants crawling in a world of adults, occasionally noticing the adults, shadows but unable to comprehend what they were doing or why. The year 2039 ended with humanity in a state of profound epistemic crisis. We had discovered incontrovertible evidence of intelligences vastly superior to us. We had partially decoded their messages and found them teaching us about reality's structure in ways that exceeded our understanding. We had detected hints of technologies that operated beyond known physics and communication systems that exceeded our ability to observe. And we had learned that the universe we thought we inhabited A cosmos governed by knowable laws, where human intelligence could in principle understand anything given sufficient time and effort, was actually a far stranger and more layered reality, where fundamental aspects remained forever beyond our grasp. The signals had shattered human exceptionalism, not through direct communication but through their mere existence, proving that intelligence could achieve heights we could recognize but never reach, creating technologies we could detect but never comprehend. In January 2040, Dr. Rebecca Torres published her fifth and final major study on the signal's psychological impact. The paper, titled Adaptation to Cosmic Context: How Humanity Learned to Live with Inadequacy, documented how the acute crisis of 2024 to 2030 had evolved into a chronic condition by 2040. People had not resolved the existential questions raised by the signal's discovery. They had simply learned to live with irresolution. The same way humans have historically adapted to awareness of mortality, cosmic vastness, and the heat death of the universe. The signals became background knowledge, an accepted feature of reality that people acknowledged without dwelling on. Education systems incorporated cosmic context into curricula. Children growing up after 2025 learned from early ages that humanity existed in a universe filled with vastly superior intelligences pursuing incomprehensible goals. This became normal for them, as normal as knowing that the Earth orbits the Sun or that dinosaurs existed millions of years ago. Torres argued that this normalization represented a maturation of human cosmic consciousness, a transition from adolescent self-importance to adult recognition of our actual place in the universal hierarchy. Whether this should be celebrated or mourned remained unresolved. Some people found a new cosmic perspective liberating, freed from the burden of thinking humanity was special, or that human affairs carried universal significance. Others found it devastating, stripped of the comforting illusion that humans mattered on cosmic scales. Torres concluded that both responses were valid, and that the long-term impact on human civilization would take centuries to fully manifest. We were living through a pivotal transition in human self-understanding, comparable to the Copernican revolution that displaced Earth from the center of the cosmos. The signals had displaced humanity from the center of intelligence, from the pinnacle of what minds could achieve. We would either adapt to this new understanding and find meaning within our cosmic context, or we would fail to adapt and collapse under the weight of our own irrelevance. But even as humanity adapted psychologically, the signals themselves continued to evolve. In March 2040, Dr. Sarah Chin's team detected changes in multiple signals simultaneously. Over a period of approximately 6 weeks, 17 confirmed signals all modified their timing parameters in correlated ways. Pulse durations increased, repetition rates decreased, and the subpole structures reorganized into new patterns. The changes appeared coordinated, as if the transmitters were responding to shared signals or executing synchronized updates to their transmission protocols. Dr. Yuki Tanaka analyzed the timing of the changes in a paper published in Physical Review Letters in July 2040, demonstrating that the modifications propagated across the signals at exactly the speed of light. The first signal to change was the closest to Earth at 2.3 billion light-years. The last to change was the farthest at 8.7 billion light-years. The time delay between changes perfectly matched light travel time between Earth and each source. This proved that the signals were coordinating their changes based on something observable from Earth. Dr. Tanaka proposed that the signal sources were responding to some event or phenomenon in Earth's cosmic neighborhood, adjusting their transmissions to compensate for changing propagation conditions or to communicate updated information. The synchronized response raised urgent questions about what event they were responding to and whether it posed any threat to Earth. Dr. Marcus Webb at Oxford organized an emergency working group to examine every observable cosmic parameter for unusual changes that might have triggered the signal response. They analyzed supernova rates, gamma-ray burst frequencies, cosmic ray flux, gravitational wave events, dark matter density fluctuations, dark energy measurements, and every other monitored astrophysical parameter. They found nothing unusual. Whatever the signals were responding to, it was either too subtle for humanity's instruments to detect, or it involved physical phenomena we don't monitor. The inability to identify the triggering event created a new form of anxiety. The signal's creators, with their vastly superior technology, could detect something happening in or near our cosmic neighborhood that we remained oblivious to. This something was significant enough to warrant coordinated changes to long-running transmission protocols affecting dozens of signals across billions of light-years. What could possibly justify such a response? Dr. Liu Wei, ever cautious about cosmic threats, suggested in a concerning paper published in Risk Analysis in October 2040 that humanity might be in danger from whatever phenomenon triggered the signal changes. If the signal-producing civilizations felt the need to modify their transmissions in response to events in our region, it suggested those events mattered on civilizational scales. We might be about to experience something catastrophic that advanced civilizations can predict, but we cannot detect. This scenario seemed like paranoid speculation until January 2041, when astronomical surveys detected an anomaly. Dr. Jessica Park at Lawrence Livermore, using data from gravitational wave detectors, identified a subtle but pervasive disturbance in space-time curvature affecting a region of space approximately 300 million light-years in radius centered on our position. The disturbance was small, producing space-time curvature variations of only 1 part in 10 to the power of 18, but it was growing. Over a period of 6 months, the disturbance had strengthened by approximately 12%, suggesting it would reach measurable magnitudes within a few years. Park's team could not identify the source of the disturbance or its nature, but its growth rate and spatial distribution suggested it originated from something approximately 150 million light-years away, approaching Earth at relativistic speeds. The coincidence of timing between the signal changes and the space-time disturbance detection was too exact to be accidental. The signals had modified their transmissions 6 months before humanity detected the space-time anomaly, suggesting the signal-producing civilizations either predicted the disturbance before it became detectable or observed it through channels we cannot access. This was the first concrete evidence that the advanced civilizations possess knowledge about reality that exceeds our observational capabilities, not just by sophistication, but by accessing information that we cannot, even in principle, obtain with our current physics. They could see something coming that we couldn't, and they had taken action in response. The question was whether their actions represented preparation for a disaster, an attempt to warn us, or something unrelated to human welfare that we mistakenly interpreted as relevant. The discovery of the space-time disturbance triggered international emergency response protocols. Every major telescope and observatory on Earth and in space was redirected to examine the region where the disturbance originated. Deep space surveys using Hubble, James Webb, and ground-based facilities searched for unusual objects or phenomena that might explain what was approaching. Gravitational wave detectors were recalibrated to maximum sensitivity, monitoring for signals that might reveal the disturbance's source. Radio telescopes scanned for transmissions or energy emissions from the affected region. Particle physicists examined cosmic ray data for anomalous particles that might result from exotic physics in the disturbance zone. The global scientific community, mobilized with unprecedented coordination, united by the recognition that something unknown and potentially threatening was approaching Earth at speeds and scales that exceeded anything in human experience. The search revealed nothing. The region where the space-time disturbance originated appeared completely ordinary in all electromagnetic wavelengths. No unusual matter concentrations, no exotic energy emissions, no visible objects that could explain the curvature anomaly. The disturbance was invisible except in its gravitational effects, suggesting it involved either dark matter, dark energy, or some form of exotic matter that interacts only gravitationally with normal matter. Dr. Hiroshi Nakamura at Kyoto proposed in a theoretical paper published in Physical Review D in April 2041 that the disturbance might represent a dark matter shockwave, a compression wave propagating through the cosmic dark matter distribution caused by some enormous event in the distant past. If two galaxy clusters containing massive dark matter concentrations had collided 150 million years ago, they might have generated shock waves that have been propagating outward ever since, finally reaching our region of space now. But dark matter shock waves, while exotic, were not particularly threatening. Dark matter interacts so weakly with normal matter that even massive concentrations pass through ordinary matter almost without effect. The Earth passes through dark matter continuously without consequence. A dark matter shock wave might cause measurable gravitational effects, but shouldn't pose any danger to life or civilization. Yet the signal's coordinated response suggested the advancing phenomenon was significant enough to warrant action. Something about the disturbance mattered in ways that a simple dark matter density wave shouldn't. Dr. Priya Sharma proposed an alternative explanation in May 2041. The space-time disturbance might not be the threat itself, but a precursor, an advanced signature of something much larger and more dangerous, following behind the initial wavefront. This idea, that we were detecting only the leading edge of some enormous cosmic phenomenon, gained support when gravitational wave detectors identified structure within the space-time disturbance. Rather than a smooth compression wave, the disturbance contained organized patterns, alternating regions of positive and negative curvature arranged in geometric configurations that resembled nothing natural. Dr. Kip Thorne analyzed these patterns in a paper published in Classical and Quantum Gravity in August 2041, demonstrating that they matched certain predictions from string theory about how spacetime responds to collisions between higher-dimensional objects called branes. In some versions of string theory, our three-dimensional universe is a brane floating in a higher-dimensional space, and occasionally branes collide, producing effects that appear in our dimension as spacetime curvature anomalies. If Thorne's interpretation was correct, the approaching disturbance represented evidence of a brane collision or near collision occurring in dimensions beyond our ordinary three spatial dimensions. The geometric patterns in the spacetime curvature were the three-dimensional shadows of higher-dimensional structures propagating through the extra dimensions, gradually revealing themselves in our observable reality as they drew closer. This explanation was deeply theoretical and relied on unconfirmed aspects of string theory, but it provided a framework for understanding why the disturbance showed organized structure and why advanced civilizations might be concerned. A brane collision could have consequences far beyond simple gravitational effects. It might alter the fundamental constants of physics in the affected region, changing how matter and energy behave, potentially making the laws of physics themselves unstable. The possibility that the approaching phenomenon might alter physical laws created existential terror that dwarfed all previous concerns about the signals. Changes to fundamental constants would not just threaten civilization but could make life itself impossible. If the fine structure constant changed by more than a few percent, atomic structure would become unstable. If the strong nuclear force changed, atomic nuclei would either fall apart or fuse uncontrollably. If the gravitational constant changed significantly, stars would either explode or collapse. The universe as we know it depends on precise values of physical constants, and any significant variation would be catastrophic. Dr. Adam Rees at Johns Hopkins calculated in September 2041 that if the spacetime disturbance represented a region where physical constants differed from baseline values by more than 5%, and if that region reached Earth, it would cause the immediate disintegration of all complex matter, reducing the Earth and everything on it to plasma in milliseconds. This apocalyptic scenario led governments worldwide to begin contingency planning for scenarios that ranged from evacuation, impossible, where would we go, to sheltering, pointless if physical laws change, to desperate attempts at defense. How do you defend against altered physics? The inadequacy of every proposed response forced a reckoning with humanity's ultimate vulnerability. We had built civilizations, technologies, and philosophies, assuming that the universe operates according to stable laws. The approaching disturbance suggested that assumption might be wrong, that the laws themselves could change, and that everything we'd built on the foundation of constant physics could evaporate in an instant. We weren't just insignificant. We were contingent, our existence dependent on the universe maintaining properties it might alter on timescales we couldn't predict. But even as humanity confronted potential existential annihilation, the signals continued their incomprehensible transmissions, broadcasting into the void with perfect coherence, impossible energy, and mathematical precision that mocked our fear. They had seen civilizations rise and fall across billions of years. They had witnessed countless cosmic catastrophes. They would continue broadcasting long after Earth was gone, whether destroyed by the approaching disturbance or by the sun's eventual death in a few billion years. The signals were eternal in ways that humanity would never be, monuments to intelligences that had transcended the fragility that defined our existence. We were temporary, mortal, vulnerable to every cosmic threat. They were permanent, surviving every catastrophe, continuing their mission across timescales that exceeded the lifespans of galaxies. In October 2041, as the space-time disturbance continued its inexorable approach and humanity waited to learn whether the universe would allow us to continue existing, Dr. Sarah Chen gave an interview to Nature that captured the overwhelming experience of the past 18 years. We discovered the signals because we were looking for understanding. We wanted to know if we were alone. We got our answer, we're not alone. But the answer raised more questions than it solved, and every question revealed deeper layers of our own ignorance. We learned that the universe is stranger than we imagined, and more dangerous than we feared, filled with intelligences and phenomena that operate on scales we cannot comprehend and according to principles we cannot grasp. The signals showed us our place in the cosmos. We are children in an adult world, occasionally noticing that the adults are doing something important but unable to understand what or why. And now, something is approaching. Something the adults noticed and responded to, something we can barely detect and cannot begin to understand. Whatever happens, whether the disturbance destroys us or passes harmlessly, we will have learned the most important lesson the universe can teach. We are small, we are ignorant, and we are powerless against forces that dwarf our comprehension. The signals will continue broadcasting long after we're gone, carrying information we could never fully decode to recipients we will never meet. And that, perhaps, is the message encoded in their existence. We don't matter, we never did. The universe was incomprehensible before we existed, and it will remain incomprehensible long after our extinction. The signals are proof that intelligence, even when it achieves capabilities that appear godlike to us, is still just another phenomenon in a cosmos that operates according to its own logic, indifferent to every form of consciousness that briefly emerges from its structure before dissolving back into the void. The space-time disturbance reached Earth 3 months later. Every sensor on the planet detected it simultaneously. And then, in defiance of every prediction, every fear, every desperate calculation, nothing happened. The disturbance passed through Earth and the solar system without causing any observable physical changes. Physical constants remained stable, matter remained intact, life continued. The event that had prompted coordinated responses from civilizations across billions of light years. The phenomenon that Chen's team had detected racing toward us at relativistic speeds. The approaching catastrophe that had consumed human attention for over a year passed through our world like a ghost passing through walls. We had braced for annihilation. We got indifference. The universe had noticed us only long enough to pass through without slowing down. But the signals, those impossible, incomprehensible, eternal transmissions, the signals changed. Every one of them, simultaneously, in the moment the disturbance passed Earth, modified their parameters once more. And this time, embedded in the new signal structures, humanity finally detected something unmistakable, a section of perfectly coherent electromagnetic radiation lasting exactly 1 second, that, when decoded using the geometric language from the primer sections, translated into a single comprehensible message. A set of coordinates, a direction in space, and one word in every human language simultaneously, transmitted with such precise understanding of human linguistic structures that its artificial origin was undeniable. Listen. The age of humanity's cosmic isolation had ended. Whatever came next would be different. The signals had spoken directly to us, for the first time in human history. We had finally graduated from observers to acknowledged participants. But participation in what? Toward what purpose? With what consequences? The coordinates pointed toward a region of space 14 billion light-years away, so distant that light from there has barely had time to reach us across the entire history of the universe. What could possibly exist at such distances that warranted humanity's attention? What were we being told to listen for? Dr. Sarah Chen directed every radio telescope under her authority toward the coordinates. And in the static and noise of the most distant observable region of space, filtered and processed and analyzed with every technique humanity possessed, they found it. Another signal. Different from all others. Weaker, older, carrying information that predated the universe's first stars. A transmission from the cosmic dawn itself. From a time when the universe was less than 1 billion years old, broadcasting from the edge of observable reality. And this signal, unlike any other, was changing in real time, responding to Earth's observations, modulating its structure in patterns that could only mean one thing. Someone was listening back,